Hi, everyone. We are in lesson 4, our last lesson before the unit test. So function families for 200, Alex. Recognizing functions by characteristics, and our learning targets for today are recognize similar characteristics among different function families and recognize different characteristics among recognize similarities and differences among function families. Okay, and this determine function types given certain characteristics. That's what we're going to do towards the end. We're going to write out functions actually. And we're going to page 64 right now. And if you notice right here, I had asked you guys, answer those 4 questions using that word bank right over there. And just as a quick explanation of this, let me see what use black today. So linear is going to be a line, right? Straight line, either this way, it doesn't matter which way, is as long as it's a straight line. And exponential is going to look like this, or it could look like that. It's like slow growth and then quick, right? Or quick decay and then it slows down, right? And then quadratic is going to look like a U, right? It's not a V, it's a U, because, or either way, U here, right? Linear absolute value is going to be the V, right? One could be like this, one could be like this. And linear piecewise is basically we take a couple of different lines, cut them all up and put them together. Okay, that's literally what that is. It's piecewise like a quilt, like I said in another video. If you watch that video, you don't know. So the graph is a smooth curve. What could that be? And some people said it's a quadratic or it's an exponential, right? Either of those work. If you said absolute value, that's absolutely not right, right? Because that was not smooth. It's like a roof, right? And so the graph is made up of one or more straight lines. So that could be linear. It could be a linear absolute value, right? Because they're made up of lines, or linear piecewise. Any one of those work, totally fine, right? And if we look at C, the graph increases or decreases over the entire domain. So increases or decreases. So over the whole entire X, domain meaning X, right? So we could go exponential, or we could go linear, right? So it's always increasing and never like drops, right? So unlike the quadratic or the absolute value, or even the piecewise, it depends on what kind of piecewise, right? So yeah, because a quadratic will go up and then go down, or the other one goes, like the V, right? It goes down and then it goes up, right? So yeah, not those ones. So these are increasing throughout the whole thing, right? All of X. And the graph has an absolute minimum or maximum. That would be quadratic, right? Because if you look at here, like this guy right here, that is a minimum. That's a minimum point because that's as low as it's going to go. And the max is going to be as high as it goes, right? And same thing with the absolute values. That's as low. So that's the min and that's the max. Okay, min meaning as low as it's going to go, minimum or maximum. All right. And we did talk about the absolute value. I felt that I didn't know if all you guys knew what absolute value was. So this is an absolute value sign, and you're like, oh yeah, that looks familiar, right? You could actually graph these, right? So if I put in a -3, what's the absolute value of -3? You're like +3, because the question you're asking yourself is, how far is -3 from 0? And so it's always relative to 0. You need to. So it's always relative to 0. So if this is 0, here's 2, 3. So there's -3. So how far is -3? If this is -3's house, how many blocks do we have to go to get to 0's house? 3. You don't say -3. Distance is always positive, right? So that's why absolute values are always positive, right? And so that's why it's 3. And so, well, you're like, well, what about +3, right? So what's the absolute value of 3? If you're over here at 3's house, right? How far is it from 0? Still 3 away, right? 3 miles, 3 inches, 3 units, whatever it is, right? It's still 3 away, right? So that's why the absolute value of 3 is still 3. It's not -3, because remember, it's talking about the distance, how far a number is from 0. 0 is always that reference point. Okay, again, like absolute value of -2.7, it's just 2.7, right? That's how far it is. Distance is always, yeah, that's why these numbers are numbered the way they are, because that's how far it is from 0, right? 0 is a reference point. All right, and now moving on. So we looked over here. So if you guys remember our This was like our first lesson that we did. Remember, Dave did the I can't say it. The daredevil, something's fishy, smartphone, but is it a smart deal, right? And what we're gonna do is we're going to do a few things here. So remember, we had talked about what kinds of graphs these were. So linear, exponential, quadratic, linear absolute value, and piecewise. And this guy right here, do you see how there's two different things going on? So here's like the first piece right here. So this is the first part of the graph, right? And then here is the second part of the graph, right? This is in pieces, right? So it's pieces. It's piecewise, but it's not linear, right? Because if you notice right here, this is a curve. So this is probably like quadratic, right? But it's definitely not a line, right? So it's not a linear piecewise, it's just piecewise, the piecewise function. Because yeah, we're taking two pieces and putting it together. And then again, with Candace, she's cleaning out the aquarium, right? This is definitely linear, right? Straight line, no mess about it, right? And if you look right here, this is gonna be an exponential growth, right? It starts off slow and then rapidly increase, right? And I need to stop saying right and saying that too much. And I can't wait to hit the slopes. Remember that he was stopped here. He was like going, and then he stopped because it broke or something like that. Something was going on. And then he went back up again. He kept on continuing, right? And this is definitely a linear piecewise, right? Three different lines you see there. This one is the opposite of this guy right here. And if you notice, we call this exponential growth, right? And this one is exponential decay. Normally we would talk about this if things are disappearing, like, if you're taking medicine, like with a virus, like a cold, and they tell you to eat medicine, right? And that medicine like cuts it in half and then cuts it in. That's why, and then there's these like straggling little bits that keep on not leaving. That's why the doctor tells you to eat it for eat the medicine for 2 weeks. So even though you feel fine, right, there's still little bits of viruses still in you. So that's why you need to continue to eat it until it's all gone, right? And so that's the exponential decay. Exponential growth is like COVID or like weeds outside your house or your apartment. If they don't weed the stuff, they don't take out the weeds, then this grows exponentially. Like especially like dandelions. Have you ever seen that? Like you see one, and then you see two, and then you see four, and then you see eight. It's just keeps on going, right? And then here's our baton, Jill, our baton drum major person. And here she's throwing it and it goes here. Oh, this is actually not the baton throw. This is Angry Birds, right? So Angry Birds also is quadratic, right? Because if you notice the curves, because it goes up and then it curves and goes down, right? So that was my little slingshot right there. And there's my pig, no, my bird. And then there's my pig right there with the little wood or whatever that is, right? And that's what that is. That's a quadratic for sure, right? Any kind of throwing, any kind of kicking, if you're kicking a ball, throwing and whatever it is, that's going to be a parabolic motion, which we call parabolic. And here we have a linear piecewise, and this is a linear absolute value. Okie dokies. And the way we could tell if it's absolute value, if this slope is the same but on opposite sides, right? One's negative and one's positive, then you're good. If this one right here was a line that was, not highlighted. So if it was like down like this, and we had this line right here, that's not absolute value. Okay, it would not work that way because remember, positive and negative have to be the same distance on both sides, right? That's what absolute value means. And that would then be a piecewise. Okay, so that's how you tell the difference. Can you have a piecewise that looks like an absolute value? Absolutely. But for now, we're just going to know that to just be absolute value. We're not going to think too hard about that. All right, we talked about domains, and it says the domain of the real world situation. There were some things that we did not know, and the graphical behavior. There's one more thing I want to add on here, which is whether it's continuous or discrete, right? Is the data continuous or is the data discrete, right? And so the daredevil, remember, it was Grayson, he was jumping off a cliff, right? And then he goes in the water, and this is what he continues to descend, right? And here remember the X value starts at 0 because this is time. It starts at 0 and it goes all the way to when he reaches the ground, which is I don't know when, or when he decides to get back up again, or when we stop the timer. But since it has an arrow, we're just gonna go infinity. So it's from 0. 0 is less than or equal to x, which is less than infinity. Okay, that's the interval. Or we could say x is just greater than or equal to 0, because time can keep on going. Time is going to keep on going until we stop it at a certain point for this scenario. All right, and something's fishy. Remember, we're decreasing. We're letting Candace, I think it was letting out the water until it goes to nothing, right? We don't have that information, so I don't know when it decreases and when it stops. It doesn't tell us in the what is it in the story, right? It says, oh, well, actually we can figure this out. It's a 200 gallon and it drains at 10 gallons per minute. So it's 200 divided by 10. 200 divided by 10 is, I can't think, 20, right? So that's just 20 minutes. So this actually goes from, so it goes from 0. So it can equal 0. That's why I'm putting equal signs, and it goes all the way to 20. All right, and it is decreasing. Also, is this discrete or continuous? Can we do like 0.5s? Can we do like time as being 0.5? Can we do gallons being 0.5 or 0.25? Yeah, right. We have partials of a gallon, right? So this is called continuous. All right, and for time, we're talking about the height, right? If we're talking about the height, we can measure height in increments, right? In like 0.5s or in decimals and all that kind of stuff, right? So this is definitely going to be continuous. There we go, continuous. And let's see, is it a smart deal or not? I don't know. Okay, so remember your cousin was loaning you money, you had to pay interest, and first week it was $1, then it was $2, then it was $4, and just keeps on doubling, right? So can we pay it off in half a week? Didn't say anything about that. So this one is definitely good. So the first week is gonna be $1, then $2, then $4, then what was it? $8, then $16, then $32, then $64, all the way up here, right? So this one is definitely not going to be like, it's not continuous, it is discrete. So this one should technically be without the line, right? Because there is no in between. They're like, your cousin didn't say, oh, well, if you do it in like a week and a half, then, it's like a little bit more than, it's not doing that. So start, depending on which week, that's how much you're going to have to owe. So don't, this guy's a shark. Don't listen to him. So again, our X can go on, or so that's our time. It can go on indefinitely. So there was no, unless I read it wrong. Pretty sure that was it. Yeah. So there is no time of like when you need to pay it back by. So that just goes on forever. Hopefully not, because you're going to owe him an exorbitant amount of money. So can't wait to hit the slopes. So this one, remember the ski lift, and then he gets stuck here. And so that one was going to be X is greater than or equal to 0 until whatever time he gets off this thing, and doesn't say what it is. So we're just going to leave it at that. X is greater than or equal to 0. And it is increasing and constant. So it increases here, then it just remains the same, because remember, he's not moving. So his distance is not increasing, and then it starts going back again. And this one, since we're measuring in height and it's in time, so this is going to be continuous, because we can, we can measure like 0.5 of a distance, right? Or half a second. Where am I at 0.25 of a second, right? Or 1.75 or 1.75 minutes in? Where am I at, right? I know there. So this is a continuous graph. And then moving on, we are halfway there. So we have, it's magic. Remember the guy, he's cutting, he has a 20-foot rope and he's cutting in half, cutting in half, cutting in half. And technically, and I talked about this in my other video, technically, he can do this infinite number of times. So it is from 0 cuts, which is 20 feet. That's what it would be. And then all the way to infinite number of cuts. But it doesn't really say how many cuts that is. What does it? yeah, it doesn't say how many that is. Maybe you could find out for me. Tell me what what the domain is. But it is definitely discrete because it's not like we're going to have like 19.9 inches, 19.9 feet, 19.8 feet. We don't have that. It's just we have 20 feet, then 10 feet, then 5 feet, then 2.5 feet. See how that goes? So this is definitely discrete. We don't have anything in between. And then baton twirling, tosses it up, goes down. Remember, it did it for 2 seconds, and there is no arrow like that because our baton is not that strong. And where's my, so there should be no arrow there. It should just stop right there. Bad. And so that was from 0 to 2 seconds. That's the domain. So when it goes up in the air until it reaches the baton twirling person's hand again. And that is increasing and then decreasing. Is that going to be continuous or discrete? If it was discrete, literally the baton, you would only see it if like you were to take a picture, a whole bunch of pictures at the same time, here, 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 here. And you would not see the time in between. That would be crazy if we saw the world like that. That's too much. So yeah, this is definitely continuous. And cold weather, remember this is the temperature. So can we measure temperature in only by degrees? Yeah, it could go decimals and all that kind of stuff, right? But what about, remember this was the number of people who go in. So this is the number of people, that is definitely discrete. So there are going to be dots. You can't like half a person, like that doesn't work out like that, right? So this has to be true for both X and Y. So that's going to be, what is it called? Discrete. Because we got people over here. That's going to be the number of occupants in the hotel is the more official term for that, I think. And it's going for, remember, our X is going to be from -20, because that's what it says in the thing, the scenario, all the way to however hot it would be, right? There was no definition of no thing for that. So just to however hot. So we just said from -20 to positive to infinity and beyond. And the jelly bean challenge. So we know that there is a certain amount of jelly beans that you could have. So the problem is, or this is actually the number of guesses, I believe, right? And this is the difference, how much it's being subtracted by. We don't know what that is because it didn't really tell us. So I just called it A, whatever that A is. What is the biggest guess for that, right? And then so it's from 0 to A. And then it decreases and then it increases. And it is discrete because you can't, well, I guess you can guess like 0.75, but why would you do that? You're never going to get that right, right? So this is going to be discrete jelly beans. Okay. And that was the end of today's lesson. And for the homework today, where are you? Right here. So that's going to be page 73. It's always at the back of the lesson. It's the right numbers 1 through 6.